Hello everyone. Welcome back to the 2026 MRT Integration B exam, and this is problem 3 on our hand, and we're required to compute the integral from 0 to 2026 of the fractional part of the floor of x dx. Now let me explain these two functions, being the floor of x and this is called the floor function, and then the fractional part of x. Remember that if for any real number you have, let's say 1.2, then the integer part, which is the floor of 1.2 is basically 1. The fractional part of 1.2 will basically be 0.2. So naturally any number x would equal the floor of x plus the fractional part of x. That is how you will definitely describe all numbers basically. So these are the floor and the fractional parts. Now this may look impossible to work out because you have a fractional part and then you have a dx. So how do we even untangle this? Well, let me tell you something for free. The integer from 0 to 1 of the fractional parts of x, actually dx, actually equals 0. Why? Because since x is between 0 and 1, the fractional part of let me just put the floor. So since x is between 0 and 1, the floor of x essentially is going to be 0. It's going to essentially be 0. So this integral here will be 0, the integral for the floor. So if we understand the inner function, we should be able to compute the entire function. So what we're not going to do is that we're going to study this function. Let f of x be equals to the fractional part of the floor of x, all divided by x. Now we are going to see if it is even periodic. So let's say in the first case, so let's say case 1, let's assume say 0 is less than or equal to x, which is less than 1. Okay, then in that case, in this case the floor of x essentially becomes 0. Okay, so this means that f of x would be the fractional part of 0 over 3, which is essentially going to be 0. Okay, so f of x is 0 when x is between 0 and 1. Now let's say case 2, when 1 is less than or equal to x, less than 2. Now in that case here, now you would get something like x is like 1 point something also. So the floor of x in this case here now would actually equals to 1, and basically the f of x is going to be the fractional part of 1 over 3, which is basically still just 1 over 3. So on this interval, x is pretty much 1 over 3. Now let's say case 2, when 2 is less than or equal to x, which is less than 3. Now the floor of x here is essentially going to be 2, and this means that the f of x would be the fractional part of 2 divided by 3, and which is basically 2 divided by 3. Now let's say case 3, okay, case 1, case 2, case 3. Let's say case 4. Let's say this case whereby 3 is less than or equal to x, less than 4. Now in this case the floor of x is pretty much 3, and this means that f of x being the fractional part of 3 over 3. Now 3 over 3 is 1, so the fractional part is pretty much 0, so you have a 0. Now we have 0, we move to 1 third, 2 third, and we get 0. Let's see if we go under interval, what happens. So let's say case 5, where 4 is less than or equal to x, less than 5. Then you have fractional part of x, of course, will be 4, and this means that f of x would be the fractional part of 4 divided by 3, which is the fractional part of 3 plus 1 divided by 3, which is a fractional part of 1 plus 1 third, which is just 1 third. So we see a repetition here, 0, 1, 2. So I think this is periodic with period 3. After the first 1, 2, 3, after 3 cycles, it will repeat again. So it is definitely periodic with period 3. And let's see why this is the case. Let's say we have case n. Let's say f of s. Let's try f of f of 3n plus x, what do we get? Well, you will get the fractional parts of the floor of 3n plus x, all divided by 3. Then the floor of 3n plus x, let's say x is very small, okay, because this is an integer, it's going to be equal to just the fractional part of 3n plus 3n plus the floor of x, all divided by 3. So if that would be the fractional part of n plus the floor of x, all divided by 3. Now, because n is an integer, that would still be the fractional part of the floor of x, all divided by 3. So this is essentially pretty much our f of x. So you can see that f of 3n plus x is f of s. Okay, so let's see, we're going to divide this 2026 by 3. If we do that, we'll get, okay, 3 goes there 6, so you have 6 times 3, that is 18. 2, so you get 2. Stay 7 times 3, you have 21. So you have 1 and 6. Okay, so you have 1, then you bring down 6. So 5 times 3, you have 15. So you have 675 plus 1. So basically 2026 is 3 times 675 plus 1. So basically the integral from, and we recall, if you check the description here, we proved earlier that the integral from 0 to nt plus a is n times the integral of f of x dx is n times the integral from 0 to t of f of x dx plus the integral from 0 to a of f of x dx, where f of x is any periodic function. So essentially the integral from 0 to 2026 of f of x, which is the fractional part of the floor of x, all divided by 3 dx, is equals to the integral from 0 to, now this is 3 multiplied by 675 plus 1 of the fractional part of the floor of x, all divided by 3 dx. So if we use our theorem, we have moreover, we have established this result in this channel before, even today. So you can check the description of this video and you will find it, the proof of this result. I wouldn't need to prove it because I don't want this video to be longer. So let's go to here. You would have n, right? N is the period is 3, so you have 675 times the integral from 0 to 3 of the fractional parts of the floor of x, all divided by 3, then plus the integral from 0 to 1 of the fractional parts of the floor of x, all divided by 3 dx. Now this is 0 because if x is between 0 and 1, the floor of x is 0, and so you have let's break this. This is 675 multiplied by the integral from 0 to 1 of the fractional parts of the floor of x over 3 dx plus 675 times the integral from 0 to 1. So integral from 1 to 2, of the fractional parts of the floor of x over 3 dx plus the 675 times the integral from 2 to 3 of the fractional parts of the floor of x over 3 dx. Now this other one is 0, of course, so this is actually 0. And also the good part is that this is actually 675 multiplied by 0, because it is 0, point being that the floor of x on this interval is simply 0, so that is 0 over 3, so this is 0. So this is now plus 675 times this. So between this 1 and 2, the floor of x is 1, so we have the fractional part of 1/3, so we have 675 multiplied by the integral from 1 to 2 of 1 over 3 dx, and then plus the integral from 2 to 3. Here the fractional part between 2 and 3, we already proved it is equal to 2/3, so you have 2/3 dx. Okay, so you have 675 times, now this is 1/3x from 1 to 2 plus 2/3x from 2 to 3. Okay, so that would be 675 times 1/3, 2/3 rather, 2/3. So 1/3 times 2 minus 1/3 times 1 plus 2/3 times 2, and then minus 2/3 times 3. Yeah, so that is that. No, 2/3 times 3 minus 2/3 times 2. Yeah. Okay, so that would be 675. Then you have 2/3 minus 1/3. Okay, that should be 1/3, right? Yeah, so let's say we'll just put it as 1/3. So you have a 1/3, and then you have 2, and then minus 4/3. So that should be this should be 6 plus 1. That should be 7/3. So this should be, so you have 7/3 minus 4/3. So that would be 675 times 1, which is 675. So the answer is 675, and that should be that for that. So it's a very somehow tricky problem, but we're able to solve it. So thank you for watching, and please do subscribe to the channel. Bye.